So remember, reflection is just a fancy mathy way of saying you're going to flip that image over a line and create like a mirror image of it. So to set this up, the first thing we need to do is see the line that we're going to reflect the shape over. Because remember, it's just like a piece of paper. You could fold that piece of paper anywhere and imagine that original shape being imprinted on the opposite face of the page when you fold it, like a stamp. So you could fold it over a lot of lines. We are just going to keep it simple and we're going to fold it over the y-axis and the x-axis. So to move that mirror line, all you got to do is grab those red dots and drag them over, and they'll kind of snap into place on a whole number coordinate on the axis. So it's sitting directly on the y-axis. And then when you click on reflect, notice it creates a mirror image directly on the other side of that line to create this new blue shape. And then you record the coordinates of that new shape, either just by copying them right off of the list there, or by taking them off of the graph over here. So notice what happens when you reflect across the y-axis is that the points don't move up or down, they just move horizontally. Because remember, we did this in the previous investigation where we noticed under reflection, the points move to the other side of the line of reflection along a line perpendicular to it. So the grid makes that easy because those grid lines that run horizontally are perpendicular to the line of reflection, which is vertical right now. And so they are the same distance away from that line on the opposite side of it. So they don't move vertically, they just move horizontally so that they're on the opposite side of the y-axis. So notice what happens with your numbers. The x coordinate just changes sign. So it goes from point A, the original point has an x value of 1, the new x coordinate of the reflected shape has a coordinate at -1. And that happens to every point. So if you look at those two lists, the only difference between this list and this list is that the sign on the x values has changed. They have opposite signs. So for the second part, we're going to flip it over the horizontal line, which is our x-axis. So I'm going to turn off that reflection. Snap those 2 points onto any nice whole number coordinate point that's on the x-axis, and you've got a horizontal line of reflection now. And then you can probably imagine before doing this that this shape is going to flip down into this quadrant. So the y values are going to become negative. Click on reflect, and sure enough, there it is. So this time, notice it's still following that same rule. The points are equal distances from the line of reflection along a line perpendicular to that line of reflection. And this time the x values stay the same, but the y values change sign. So all of those y values, the second number in each coordinate, has gone from being positive in the original shape to negative in the new reflected shape. So it's just a sign change. Now we're just going to keep it simple and only look at reflections across the x-axis and y-axis, changing the sign on your x's or the sign on your y's to get those new coordinate points. But notice, hold on, you could reflect across a lot of different lines, and no matter where you put it, it'll follow that rule. You can imagine if this was our line of reflection right, let's say we put it right here, you can imagine making predictions for those coordinates. If you reflect it across some other diagonal line, gets really complicated. This is some really fairly gnarly geometry. If we wanted to predict, like if we knew the equation for this line or what angle that line was running at, we wanted to predict where A would end up, really, really complicated. So we're keeping it simple, just looking at reflections across a horizontal or a vertical line, kind of like these. So to sum up in our notes, first of all, your data table should look something like that. And so notice from the first row to the second row, you can see where your x values change sign. From the first row to the third row, you can see where your y values change sign. So to summarize what happens when we reflect the coordinates of one of these shapes, we want to describe how the coordinates of a polygon are changed by a y-axis reflection. So that's when the line of reflection is the vertical line. And so y coordinates stay the same, the x coordinates change sign. And so if the x coordinates start out positive and you reflect them over the y-axis, they become negative. If the original figure had negative x coordinates and you reflect it across the y-axis, they would become positive. And on the flip side of that, how the coordinates of a polygon are changed by an x-axis reflection, you just basically switch x and y. Okay, out of my original little erroneous one there. But in this case, the x coordinates stay the same, and the y coordinates change sign. So check your notes, check your thinking on those, tinker with the manipulative a little bit more if you need to, and then move on to the last part of the exercise.